dive a bit deeper into complex fractions. I put an example of these into the crash course they went through last week. Let's really focus on how to deal with these fractions inside of fractions. So taking a look at the top part here, I have x over 6 minus x over 3 all over x over 5 minus 7 over 10. Now notice that I do want to combine these things. Let's go ahead and take a look at the top part here. If I multiply this top and bottom by 2, then the denominators here will both be 6. So I could combine these into one giant fraction. If I take a look at the bottom, if I do this one by top and bottom by 2, then both of these will be 10. And this bottom can become one giant fraction. That's what I'm going to go ahead and do. So right here, I'm going to say take this one, multiply top and bottom by 2 over 2. Same thing here, 2 over 2. Let's go ahead and write out what we have now. So I have x over 6 minus 2x over 6 all over 2x over 10 minus 7 over 10. Let's go ahead and combine them so I can actually see how they're one fraction. So x minus 2x, that's negative x over 6 all over 2x minus 7 over 10. Now, for the sake of making this a bit easier to see, for a moment, I'm going to rewrite it as negative x over 6 divided by 2x minus 7 over 10. Now, this is a step you don't have to do. The reason I do it is because back in middle school, most of us probably learned that if I see it this direction, I can change it to become multiplying by flipping this one upside down. So basically, dividing by a fraction is multiplying by the reciprocal. So basically what I'm going to do is I'm saying that this is the same thing as negative x over 6 times, now flip the other part, 10 over 2x minus 7. So that's what I'm going to go ahead and look at, and now I want to go ahead and simplify that. So this 6 and that 10, well, they're both even numbers. So let's go ahead here. Let's divide 10 by 2. I'm going to get out 5, divide 6 by 2, and I get out 3. So what I now have is negative 5x on the top, and on the bottom, I have 6x minus 21. I just went ahead and multiplied that 3 back in. You can leave it out if you wanted. That is up to you. So what I have here is that is the simplest form of this answer. So negative 5x equals 6x minus 21. And let's go ahead and take a quick moment to take a peek at the domain. So remember, I'm worried about when the denominators of any of these fractions have x's in them. So check the start off. I have 6 and 3, 5 and 10. That's not going to bother me. I keep going. I have 10s and 6s. I keep going a bit longer. And then notice, well, something's going to happen here. If this 2x minus 7, if that chunk becomes 0, then my whole bottom will be 0. And I can't divide by 0, so that'd be an issue. So let's go ahead and check for that. So 2x minus 7 equals 0. That's where I might have a problem. Go ahead and add 7 to both sides. 2x equals 7. Divide by 2. X equals 7 halves. So that's going to be a problem. That's one of the values. I keep tracking through and I come down to here and I see that I have 6x minus 21. But do notice the 6x minus 21 came from right here. It came from 3 times the 2x minus 7. So by dealing with it here, I've already dealt with this case. So in terms of my domain, the only value I can't have is 7 halves. Because again, I can't have a denominator go to 0. In this one, I have 2 over x minus 4 over 2 over x plus 3. Now, as before, I'm going to have to get this to be one giant fraction and one giant fraction. Notice that the only thing in the denominator is really an x for this one and an x for that one. So if I think about this as 4 over 1 and 3 over 1, to make them be the same, top and bottom by x. Let's go ahead and write out what we have now. And I'm going to go ahead and combine my two steps. unlike last time. Notice the bottom of this is now x. The top is 2 minus 4x over x, big fraction bar, 2 plus 3x over x. And let's go ahead and rewrite this. So 2 minus 4x over x divided by 2 plus 3x over x. And remember, I'm doing this that way. Remember that I'm going to say, instead of dividing by this fraction, I want to multiply by the reciprocal. So 2 minus 4x over x times, I'm going to go ahead and show that flip upside down. And we always flip the second one, never the first. X over 2 plus 3x. And I come through and say, okay, do we have anything in common? And we do. Both of these have an x. So that x term is now gone. I am left with 2 minus 4x over 2 plus 3x. Okay, so that's going to be that simplified form of that rational function. Let's go ahead and check for domain. So notice here that I have a 2 plus 3x in the bottom, and that's going to be a problem. So 2 plus 3x, what causes that to go to 0? Well, let's go ahead and subtract the 2 to the other side. 3x equals negative 2, divide by 3. X equals negative 2/3 will be a problem. And we have another one. I have these x's I canceled out, but also visible over here. I have an x in the bottom, so the other issue is that x equals 0. So my domain is all real numbers, but x is not negative 2/3, and it's not 0. Alrighty, last question for this example. So I have 3 over x plus 5 all over 2 over x minus 3 plus 1 over x plus 5. Now the nice thing this time is that this part is just kind of done. I'm going to leave that there. What I have to worry about is the stuff in the bottom. So notice that I do need a common denominator. I'm going to have to multiply top and bottom by the x plus 5 and this top and bottom by the x minus 3. Let's go ahead and show that. So over here, I'm going to do x plus 5 over x plus 5. And on the other side, I'm going to do x minus 3 over x minus 3. So big multiplication there and on that other side. All right, let's go ahead and write out what we have now. So I have 3 over x plus 5, big fraction bar. And over here, notice that we will have to distribute, okay? So we're going to do 2 times x and 2 times 5. So I have 2x plus 10. And on the other side, I'm going to have 1 times x and 1 times negative 3. So plus x minus 3. And the nice thing is, everything in that bottom now is x plus 5 times x minus 3. So all this stuff here is x plus 5, x minus 3, because I got common denominators. Let's go ahead and simplify what we've got. So I have 3 over x plus 5, big fraction bar. 2x plus x is 3x. 10 minus 3 is plus 7 over x plus 5, quantity, x minus 3. Okay, I'm going to go ahead and let's actually make this a bit more obvious. This here is the big fraction bar. I'm going to go ahead and rewrite it using that division for a moment. So I really have 3 over x plus 5 divided by 3x plus 7 over x plus 5, x minus 3. And remember, dividing by a fraction is the same thing as multiplying by the reciprocal of that second value. So 3 over x plus 5 times, again, these are now ready to switch. So in the top, I now have x plus 5, x minus 3, and in the bottom, I have 3x plus 7. Alrighty, let's go ahead and cancel out whatever they have in common. So basically, if I divide top and bottom by x plus 5, these here are now gone. I will be left with 3 times x minus 3, and the bottom will be 3x plus 7. Well, 3 times x minus 3, that's going to be 3x minus 9, and the bottom is 3x plus 7. So this part here is as simplified as I can. Let's go back and check for domains. So what I notice right here, that 3x plus 7 is in the bottom. Well, that's going to be an issue. So 3x plus 7 equals 0. Subtract 7 from both sides. 3x equals negative 7. Divide by 3. X equals negative 7/3. That's going to be one of the issues. Let's keep going back and tracking this all the way through. As I take a look here, I see that I had an x plus 5. That means another point of issue will be x equals negative 5. And I keep looking through here, I see that at one point I had x minus 3. So x equals 3 is going to be another issue. So in terms of our domain, x is all real numbers, but it is not negative 7/3. It is not negative 5, and it is not positive 3.